Hello everyone and welcome. Today we're going to be going over developing in AWS and how to deploy .NET code from Visual Studio. So if we look at this, what we want to do first is take Visual Studio plus AWS Visual Studio Tools and that equals productivity, and that's what I hope you get out of today. We're going to look at the services we offer, and specifically we're going to look at services that you would use with your .NET 4 code or your .NET Core code. We're going to also talk about some continuous integration, continuous deployment pipeline tools as well. So to start with, let's talk a little bit about the toolkit for Visual Studio. It allows us to do a lot of things right from within Visual Studio, and we won't cover all of them today. But it allows us to manage virtual machines. Basically, we call them EC2, Elastic Compute. It also allows us to create and manage our networks, or virtual private networks. There are virtual private clouds, we call them. It also allows us to manage storage areas, specifically S3 buckets. Another thing we're going to look closer at is Elastic Beanstalk. And deploying your code to Elastic Beanstalk lets you take your code and put it out on servers that are accessible on the internet with a simple publish click command. And then we can have a complex infrastructure environment built for us automatically. Another thing you can do with it is cloud formation. You can also do SNS events, texting type consuming and sending events. We can also use queues. We can also manage users and rights in our tool called IAM of what rights they have within the AWS cloud environment. We can also manage databases, as well as CloudFront distribution of getting our data closer to customers. And lastly, DynamoDB in creating and editing databases there. So these are the things we can do with Visual Studio, the toolkit. And what I'm going to look at first is Elastic Beanstalk. So if we take a look at different things we can do with Elastic Beanstalk, it supports multiple languages. It allows us to run our .NET 4X code. It runs on Windows Server 2008 R2, 2012, 2016, and it allows us to run our traditional code that we've had without any real changes, to just publish it and run it without having to set up and manage the infrastructure ourselves. Some other nice features are URL swapping, or blue-green deployment. So I can have hot sites, install my test code, and then basically switch the URL over to the new site after I've tested, made sure it works. The old site is still up, and so if we need to fail back, we can easily switch the URL out and go back to the other site. So some pretty cool stuff in Elastic Beanstalk. If we take a look a little bit more at it and look at the architecture that we can set up with this, we can do it more simplistic with just one server to keep costs down that we might do in a development environment. But in a full production environment, we can do a very complex setup, and here is something probably similar that you've seen before, a three-tier application architecture. Now what we have, the A and the B in those little sections, those are actually separate data centers. And so one of the really great things with our AWS Cloud Fabric is we have very fast speed networks between data centers in a region. And so I can set servers up in different data centers, and they can communicate in under 2 milliseconds. What that really means is I can work with them just as they're in the same data center. And so what we have here is the database on the back is synchronizing data. You can only access one database at a time, but we do have the failover to another data center and the failover of the data. Then we have middle tier servers if they're needed. If they're not, we don't need to put them in there. If the databases aren't needed, we don't put them in there. And we have the web tier. And we can scale out both the mid tier and the web tier servers, which means based on demand, on CPU load, on number of users, I can add more servers to handle a higher load, and then when the load goes down, I can reduce those servers. And so we have load balancers placed in front of that. All of this can be set up magically with a deploy, and you don't have to do any of the work of creating servers, managing, patching servers. That's all handled by Elastic Beanstalk. And so that's one of the really great features in Elastic Beanstalk, is that scale up, scale down, and fully managed servers for you so that you don't have to do the grunt work on that. As well as having the load balancers there and them added to the load balancing environment. Another tool is AWS Lambda. And in this area, it's a serverless environment. So serverless is really great for a couple things. One is, again, no servers to manage. In the other area, we're managing the servers for you, but you do have dedicated servers. In Lambda, you're accessing a shared pool, a shared farm of servers, a shared cluster. And so you don't manage those servers. You manage your code that goes and runs there. And the other really cool piece about Lambda is when the code executes, every time it gets, whether it's hit by an endpoint by a user, for example, going to a web page, or instituted by some other code call, it spins up a new process for each one of those. So it's continuous scaling in that it scales up automatically across that cluster, and each one is its own process. The other really huge benefit here is I never pay for idle servers that are sitting there. Usually you have servers sitting with a port open, listening, waiting, and there's a lot of times that it isn't even utilized. And so here we're only going to be charged for the time the code executes. And so that can be a huge differentiator. So if we take a little bit deeper look at that, in serverless, the first scenario I have here is I have 2 servers up and running in EC2. They're virtual machines or instances that you would manage and do all that. We're also taking and using the lowest cost we can get out of that by taking something using reserved pricing 1 year up front. And so that I can do for about $2.97 a day. I have these 2 servers up and running, and in this scenario we're going to serve 16,000 requests a day at an average of about 200 milliseconds of CPU usage on that. If we compare that to what we would get when we use Lambda, in a Lambda environment, we're going to pay for just the execution. And so the comparison is for that 3,200,000 milliseconds of CPU usage, that costs us about 5 cents. And so it's a huge, huge difference between about $3 a day and 5 cents a day. And that's what Lambda can give us. If it's not being accessed, it's not charging you. And so huge differentiator when we look at serverless. So from a cost comparison, that's great. From a usage and building, it's a completely different design. One is you can't just take your version 4 .NET code and run it there. It's actually using the .NET Core. So .NET Core is required. It's also not running in a traditional app. The best scenario to set this up is to use microservices and have the microservices work together to build out an application. But the way services work is they're event-driven. So whether there's a change in state, like say your S3 bucket gets files added to it, somebody uploaded something, you could kick off a Lambda event due to a change of that S3 that it's got a new file or a file deleted. You can have requests to endpoints. So we can have ports that when someone hits a port, just like on a web server, when someone accesses the web server, that's a request to an endpoint. And so we can have requests, and we can build basically responses to web requests or to web service requests, or a change in the resource state. And that's a resource inside AWS's environment. Something changes inside your configuration in AWS. And then we kick off that process and it runs. So why .NET Core? .NET Core because of several things. One is we've built this environment and our clusters are running Amazon Linux. And so .NET Core runs on cross-platform on Amazon Linux. It's a low memory usage design. It's modularized, and it works really well for this. So that's why we're set to .NET Core apps and not running full-blown version 4 of the legacy .NET apps. So that is the aspect of Lambda. Now, if we move on to continuous integration, continuous deployment pipeline type information, we're going to look at source, build, test, production. In a source environment, certainly you can have a Git repository. You can have your TFS repository. You can have any of the source repositories you want in source. And then in build, you can have automated build put in here and automated testing, and then have that pushed into production automatically. And so we have several tools that help in this environment. Certainly you can mix and match third-party tools, other tools, Microsoft tools in this scenario. But instead of compiling on your actual Visual Studio environment, grabbing your source code and then uploading your compiled binaries after you've compiled locally on your machine, we can have these things happen just by putting them into the source code library. Because of that change in the source code library, it kicks off the build, test, and even production process. So the tools that we have in this environment are several. We'll start with AWS Code Pipeline, which is a tool which manages the source, build, test, and production pieces and puts those together. It doesn't require our tools to be the source. It doesn't require our tools to be the build. And certainly we don't have test environment there yet, so it would be third-party tooling in the testing aspect. And then in production, we could use one of our tools or some other tool that you have. And so Code Pipeline does the management of that pipeline, as well as requiring custom intervention or specific manual intervention in between. So for example, after it passes the build and test scenario, before it goes into production, we can still have it require some user interaction to sign off on it before we go and update the production environment. In the code commit section, this is an area where we are running a Git server on top of AWS, but the benefit is you don't have to manage the underlying OS or the server, the code itself and patching. You just check your code in, and that's it. And you don't have to use the code commit. All of these tools can be used independently of each other. It's just the code pipeline strings them all together so that you can use them to work together. And then so from code commit goes to code build. At this point in code build, we support the .NET Core. We've been looking at and building the .NET 4 code, but we don't have that in production yet. And then, of course, the testing, and then lastly, code deploy, which would put the code into production. A new service that we have in this area is also called CodeStar. And what CodeStar gives us is it gives us the templates built around that whole pipeline aspect. So there's templates in here. There are C# templates as well, where I can go and grab the entire environment. If I set, it will basically put in sample code. It will string together the entire pipeline of storing my code. Of course, we're going to use our tools for the custom environment that we set up. But it will string together that whole part from checking your code in to a Git repository, to the testing, and to the production deployment, and the build as well. So that's what CodeStar gives us, is putting those pieces together of all those parts. Another new feature that we've released is Visual Studio Team Services and TFS integration. So what we can do is you can publish to that as your repository, and then it goes automatically to code build after that, and can continue down in that pipeline. And so this is a install that you can grab off of our website, where you can either hit the install button on the left, the green one, and that's going to install it into your Visual Studio Team system environment. So if you're logged into the VSTS online, it'll add that. Or if you want to use a TFS server that you have on premises, you can hit the download button and install the code into your TFS server, again, and integrate into the whole CI/CD pipeline. Now, how do we get started here? The way to start is what we're going to do is either install from an MSI installation or use the Nuget packet manager. If we download the MSI package, it installs not only the SDK for .NET, but it also installs the Windows PowerShell tools, and then the SDK for managing the environment in AWS as well. If I install from the Nuget package manager in Visual Studio 2017, and I'll take a closer look at that, we'll go and demo that. But that is going to install just the toolkit for Visual Studio and will not install the PowerShell tools or the .NET tools. So if the SDK and the PowerShell tools are of interest to you, and for many of our developers they are, those you're going to want to grab from the MSI installation. So installing using the MSI, it's a download, next, finish installation. You've probably seen several of those in the past, and so let's move on. The Nuget installation is a wizard-based installation as well. You can certainly do it from the command line. We'll look at in Visual Studio and how to find it in Visual Studio, but it's a standard way to install extensions to Visual Studio, so it should be pretty easy and common for you. So with that, let's go take a look at how this works. Let me share my screen here. Okay, we should all be seeing my screen. And the first place I'm going to start here is in Visual Studio. And let's start with taking a look at how do I go and add the Visual Studio, the AWS extensions for Visual Studio. The first place to go would be to Tools and Extensions and Updates. From here, you can see I already have it installed, but you would search for AWS and it would bring it up, and then you would hit Install. I already have it installed, so we won't have to sit and watch paint dry as it comes down and installs. Once it installs, we have a profile that we have to set up. If I were to set up a new profile, and I can do that to work within multiple accounts, and I can have them to switch between, I can set up a new account, and then I get an access key. This access key is basically the key to the account along with a secret key. These are very long strings that come from your IAM or from the AWS environment. And so you create the user or the programmatic access user in AWS, and this is where you configure that. Once that's configured, you'll have different accounts that you can choose between. So the next piece, let's take a look at the AWS Explorer. This AWS Explorer is how I access all kinds of pieces of the environment. So if I want to go do things in CloudFront or DynamoDB, this is where I look at that. If I want to go into my EC2 instances or my virtual machines, that would be in this section here that I can manage those. And so what we're going to first do is just take a look at a code environment and work within that. So let me just take this web application here. And so with this web application, the first thing I would probably do if I was to run it and build it would be build it locally here. And so if I build locally, if I compile locally and then upload, that is one way that people will build their applications. But instead of building this locally by selecting, right-clicking and selecting build, there's another option here that I have, which is published to AWS Elastic Beanstalk. And this application here is a standard application. It's just a Microsoft standard app. And so instead of building it locally, let's go select public to Elastic Beanstalk and see what comes up. We have the wizard, which I can either create a brand new environment or redeploy it to an existing environment I have set up. And we'll start with create a new environment, because that lets us go through and choose several things. One, I've got my application name. And let's see if this is a unique name for us. It is. So we're going to take the web application and publish that out. It checked our DNS name that is unique in the world. And then I can choose my target environment. Here I have Windows Server 2016 that it would be running on with IIS 10. Or I can choose a 2008 server or whatever I'm interested in that aspect. I choose a key pair, which is going to give me the ability to remote into those machines. So I can RDP in and make changes to the actual machine itself. Another thing I get to choose here is the size. And we have all kinds of different sizes and nice large. If I want to go up to, let's say, 200, let's say an R8 8 extra large with 32 processors and 244 gig of RAM. I can certainly do that, although I do like to do the T2 micros. The reason I like to do a T2 micro is because they are included in that free tier for your first year of your account, and so therefore I don't have to pay anything for this server. We hit next. It looks at the roles that it needs. Okay, I just hit next. And then am I going to do debug, or am I going to do the release? And then what about my runtime, the .NET 2 or the .NET 4 runtime? I'll keep it at .NET 4. Hit next. And then we're ready to go. And I hit deploy. Now when we deploy these, they take about 5 minutes to set up. So I won't bore you with watching 5 minutes of that deployment. I have one already baked, just like the cooking shows. And the way I find information about that is I come down to Elastic Beanstalk here. And inside Elastic Beanstalk, I can right-click on this and view status. And I can see the status of my server environment. And I have an environment here built as well. And so this code environment, if I right-click, I can view the status of that. So as that page comes up, we've got a couple things in this view. We have the URL to go launch the page, and it's up and running on that page. So if I click this, here my basically demo environment will come up. We'll come back and check that in a second, but it will come up. Then we have monitoring, and we can see the usage and the requests, and we'll see my request that just hit it even. We can look at resources. If there's load balancers in here and what is being utilized, we can see that. We can look at the server or servers. We can change the sizes of those servers. We can go into the load balancer and select how that's going to work, how often it checks for health. We can look at auto scaling and minimum counts of servers and the maximum counts of servers and what availability zone or what data center we're going to have it in. And so this environment is where we set this up. Now we ran this. Let's go click on it again. It should be up and running. And it is not coming up yet. But, oh, there it goes. It's almost up, I think. We'll come back and look in a minute. Okay, so another piece we had talked about was the storing of this code. And we might want to store this code into a code repository. So if we look at that, we can come down in the Solution Explorer and click on the Team Explorer section. Because when I'm storing code in the repository, another thing I might be doing is we might have a team that accesses that repository. So in the Team Explorer, I can either do Visual Studio Team Services, or the new piece that we have added here is a AWS Code Commit Git repository. And so I have this application built in here, but this is where I would go and have my code synchronize. So as I change my code locally, it will automatically fill in my local repository, and then my local repository will sync with the AWS Code Commit repository. And so therefore, all my code will be available to my other team members, as well as can kick off the pipeline of doing a build environment, doing testing, etc. So that is all accessed from this section here. Okay. Next, we want to move on to look at Lambda. So I don't have any Lambda environments built yet, but let's say I want to create a Lambda environment and play around with that. I can go to build a new project, and then there's AWS samples here. We have code samples that we can play with. And here's an AWS Lambda sample environment. And so I want to create an AWS Lambda project in .NET or in .NET Core in both of these. But one's a serverless application, one's a project. Let's go choose project. Call this the AWS project. It starts off a wizard, which is going to take us along the scenario here of we select a function. We'll just take an empty function, and then we create that. Now, this is the serverless environment, so I can build that straight from here, and that is what I had to show. But let's see if that web page came up yet. It did not. Oh, here it did. Here's our page. So it took a little bit to start, but let's go hit that. As it was a .NET app, it was the first time we ran it. Let's go back to my My application, this is it. We hit that string. There we go. Now it's nice and fast. Now if I go to, let's register as a new user, that page comes up, and our app is up and running, accessible on the internet at this name. So if you care to check that out yourself, you can hit that on your own browser right now. All right, that's it for the demo here. Let's go back into presentation and finish it off. Okay, so what we saw there was Visual Studio with the AWS Visual Studio Toolkit. And hopefully the idea you got out of this is if you use this, you can increase your productivity, whether it's working with .NET 4X apps and building your traditional applications you've been working on and having them publish out, or if it's working on some new type of applications, Lambda being one of the types that I would think about. But there are other application aspects you can look at with C#. But certainly I think Lambda would be the area that we look at as the best aspect to go look at as far as lowering costs and creating some new dynamic apps that are backed by web services. And I would take a look at Lambda first if you can do a new greenfield application. So by making use of these managed services, we can improve productivity, and we don't even have to leave Visual Studio for building applications, dev, test, and production quickly and easily. And so on that note, we're going to move on to questions. And let's, before we answer any questions, let me just say thank you very much for taking your time and attending today. We appreciate you investing time with us.